Unit 2 Forces. So first we have static forces where sigma F equals 0, where nothing is moving. All the forces add up to 0 newtons, and basically the newtons units are kilogram meters per second squared. Now we have kinetic, which is sigma F equals mass times acceleration, and that's when something is moving. So as you can see in the picture, we drew a box sliding down a small ramp. And lastly, we have rotational, which is sigma F equals mv squared over r. And what's interesting about rotational is that without friction, we would not be able to go into circles. And we drew the moon orbiting around the Earth for this one. And now we have static forces. Sigma F equals 0, all the forces add up to 0 newtons. And this is when objects are not moving or have a constant acceleration. And again, we say that the forces are measured in newtons, which are kilogram meters per second squared. Now we have dynamic forces. Sigma F equals mass times acceleration. So this is used when objects are moving, like a block sliding down an inclined plane or a block sliding down really anything. And moving would be not a constant acceleration. So if it's accelerating at a constant speed, acceleration is 0, and yep. So for rotational, we have force equals mv squared over r, which should be sigma F. All the sum of the forces equals that. And this is used when an object is rotating around in a circle. Or, well, it's going to be a circle in every case, but around another object as well. So the main laws in forces are Newton's 3 laws. And the first one states is the law of inertia. An object in motion will stay at motion. And an object at rest will stay at rest. The second law is the force equals mass times acceleration, the one that we used for kinetic or dynamic forces. And then the third one, for any action, there's an equal and opposite reaction. So here's our example problem. It is 2 blocks sliding down an inclined plane, one pulling the other one up. So tension is a matching force, so tension equals mass times gravity. In this case, sigma F equals 0, tension equals mass times gravity, which the mass is 10 times 10 for gravity, and you get 100 newtons. For the next part, we drew a free body diagram. Normal force goes 90 degrees from the surface, force of tension goes up, and the force of gravity goes straight down. Force of friction also goes in the opposite direction of travel. The force of gravity has to be separated into 2 directions since it's at an angle. So force of gravity y equals mg cosine 60, and force of gravity x equals mg sine 60. And you get your 2 answers there. I drew another free body diagram with the answers representing what we got. For the next part, we have sigma F of the x equals 0, and then so we have force of friction plus force of gravity in the x direction, which equals the tension force. Force of friction plus 87 equals 100, and force of friction equals 13. So for the next part, we are determining the unbalanced force. So I drew another free body diagram because the pictures always help represent the problem in your head so you understand what you're solving for. And basically here, the sigma F equals the force of gravity in the x direction minus the force of friction, which is 87, minus the force of friction, which is 7.5, and we got the 79.5 newtons in the direction down. Since this is a vector, we had to include the direction. Here we explain how we got force of friction. We use the formula force of friction equals mu times force of normal force, which is where we got 7.5. The normal force just equals 50, which it tells you that in the problem. For the last part, we're determining the speed of the block when it reaches the bottom of the plane. We use sigma f equals ma. 79.5 equals 10 times a equals 7.95 meters per second. We separate this in x and y components. A equals 7.95, d equals 2, v1 equals 0, and v2 is what we're solving for. We use a kinematic v2 squared equals v1 squared plus 2ad, and after we plugged everything in, we got as our final answer was v2 equals 5.64 meters per second. Here are all the formulas for Unit 2. We went over most of them in the video. Pause it and look back at these if you would like to study them. Thank you. Bye.